Hi Igor, how are you doing?
Hi, Josip. I want to go back home and I can't because of these travel restrictions. Why is this year such a mess?
Great question. Actually, I looked deeper into the topic and I found secret information. You might think it's the pandemic, but the pandemic is only a symptom. The main reason for the problems is that the planets went off their tracks.
Are you sure that you don't have
Oh, I'm
temperature?
totally fine, and I can prove my theory to you. We can compute the tracks the planets should have. In science, it's called the n-body problem. It's the problem of simulating a number of objects in a system and how they interact. Then we can compare the results with the current position and find the error.
Wait. Suppose you're right and there is something wrong with the universe. But I want to go back home till the end of summer and it will take eternity to compute all these interactions and sum them up. But if there will be a fast method, it will be definitely not so precise.
What if I tell you there is a fast and precise method? It might sound impossible, but that's why it was so hard to find info about it. I had to hack archives of secret organization called Praise Summer of HPC, and here's what I found. The fast multiple method, or the FMM. This algorithm allows faster computation of particle interactions by grouping them together. Imagine a simplified 2D model of our universe, where each of these dots is a planet. This 2D universe model is decomposed into small boxes, where each box is represented by a single multipole or local expansion. Now consider a point in which we want to compute the force. Consider the box in which the point is located. That's our target box. Local expansion is done for the neighboring boxes and the multiple expansion for the non-neighbors. Now when computing a force at a certain point, instead of accounting for each particle in each box, only these single expressions are considered. That's how the complexity gets reduced. To get the results, these expansions need to be rotated and shifted from their position to the position of the target box. To get more speed, we focus on the rotation. Now, the expansions are the approximations of our groups of particles, and they are approximated to a specific order. They are determined by complex coefficients. By increasing the order, the number of coefficients increases. That's why the multiple expansion can be represented as a triangle of cubic boxes, where each box is a complex coefficient. To do the rotation, coefficients of the multiple expansions get multiplied with the corresponding coefficients of the rotation matrices. Since the dimensions of the rotation matrices increase with the order, together they can be represented as a pyramid. Hence, the rotation can be represented as a pyramid triangle multiplication. Based on the documents, the process can be boosted. I lost the track of info at this point, but I know the pyramids hold the key. It's all up to you now, Igor.
Then it's my quest to find an answer in the pyramids.
I solved it! Rotation as a main bottleneck of the FMM solver can be optimized in such a way that independently on the multiple position, we need to perform the same rotation for a lot of multiples. When we want to do the same operation in parallel on a large-scale data, GPU programming with CUDA comes into play. To benefit from GPU usage, we need to stack triangles of several multiple togethers. Then each CUDA thread inside the block of threads will be working with only one multiple from the stack, but the rotation pyramid will be shared in the memory of thread block, so there will be less cache misses in the process of multiplication. Josip, can you hear me? Is it possible to program this?
Of course it is. I ran the simulations and it turns out planets really did go off their tracks. However, when we started doing HPC, they started going back to normal. Therefore, doing HPC and exploring about it must have a positive impact on the universe.
Let's all make the best out of available computational resources to save our planet.